press the bell icon on the YouTube app and never miss another update.
Hello students, ಇವತ್ತು ಪ್ರಿಪರೇಟರಿ ಎಕ್ಸಾಮಿನೇಷನ್ ಕೆಮಿಸ್ಟ್ರಿ ಪೇಪರ್ 1 ಬರ್ದಿದ್ದೀರಾ. ಹೋಪ್ ಎಲ್ಲರೂ ಚೆನ್ನಾಗಿ ಬರ್ದಿದ್ದೀರಾ ಅನ್ಕೊಳ್ತೀನಿ. ಲೆಟ್ ಅಸ್ ಮೂವ್ ಆನ್ ಟು ದ ಡಿಸ್ಕಷನ್ ಆಫ್ ದಟ್ ಪೇಪರ್. ಸೊ ಲೆಟ್ ಅಸ್ ಸ್ಟಾರ್ಟ್ ವಿತ್ ದ ಫಸ್ಟ್ ಪಾರ್ಟ್ ಎ, ದಟ್ ಈಸ್ in part A. Let us move on to the part A carries 1 mark questions. So let us move on to the first question. What is the effect of increase in pressure on the solubility of gases in liquid? So the answer for this is increases in pressure increases the solubility of gas in liquid. So just you write a word increases, then that carries 1 mark. So let us move on to the second question. Second question, it is what is the value of mixing, delta H of mixing for the binary solution of water and alcohol? So delta H, change in enthalpy of mixing, is positive for this case of binary solution of water in and alcohol, because water gives a strong intermolecular force of attraction, and alcohol, after adding the alcohol, the hydrogen bonding strength decreases because alcohol containing alkyl group, it is hydrophobic group. So therefore delta H of mixing is positive for the binary solution of water and alcohol. The third question is write the redox reaction taking place in Daniell cell. Exactly how to write this equation along with the subscript which indicates the physical state. Zinc solid combines with Cu2 plus aqueous medium, gives rise to zinc Tu2 plus in aqueous medium and gives a solid copper, and that carries 1 mark. Let us move on to the fourth question. For a reaction A gives products, the rate law is given by R is equal to K into A to the power of half, because it shows that molar concentration to the power half. Okay, what is the effect on rate of the reaction if the concentration of A is increased by 4 times? Here concentration of A, molar concentration of A is increased by 4 times, 4 to the power of half. This is the sum of the powers which indicates the order, and root 4 which is nothing but 2. Need not to write this much, you can write it just the rate of reaction increased by 2 times, that is enough, or doubles, that is also correct. Okay, now move on to the fifth question. Which type of colloids is also called irreversible salt? Leophobic colloids is also called irreversible salt. Just you have to write leophobic colloids. Okay, now move on to the next question, sixth one. Complete the reaction. So XeF2, xenon difluoride, dioxo difluoride, gives rise to only one product you need to write, xenon hexafluoride with the liberation of oxygen. So just you can write this xenon hexafluoride, so that carries 1 mark. Next one is which noble gas does not possess NH2NP6 configuration? It is helium. Even you can write the symbol also. Now what is the next question, eighth question. What is the stereochemical change observed during SN1 reaction of haloalkane? So during SN1 reaction, the stereochemical change is racemization. You need to write the racemization, or you can write it results in the formation of, the product results in the formation of racemic mixture. That also you can write. This is for SN1 reaction. For SN2 reaction, it is inversion in configuration. Next one is question number 9. Write the name of the following reaction. In the reaction, benzene reacts with carbon monoxide and HCl in presence of anhydrous aluminum chloride and cuprous chloride, and it gives rise to benzaldehyde. and the reaction is called Gutterman-Koch reaction. Name of the reaction is Gutterman-Koch reaction, that carries 1 mark. Now, name the simplest amino acid. RCHNH2COOH is the general formula of amino acids, where R, if it is hydrogen, you'll get a simplest amino acid called glycine. RCH, so that is CH2NH2COOH, you will get, that is nothing but glycine. That is the simplest amino acid, and that carries 1 mark, and this completes the part A. Now move on to the part B. In part B, the questions carries 2 marks. Write the differences between amorphous and crystalline solids with respect to shape and nature. You have to write the differences only with respect to shape and nature. Crystalline solid and amorphous solid, each differences carries 1 mark. Okay. So crystalline solids have definite characteristic geometrical shape, whereas amorphous solid have irregular shape. And crystalline solids are true solids, whereas amorphous solids are pseudo solids or supercooled liquids also, you can say. This is about the shape and this is about the nature. Only these two differences you need to write, because it is with respect to shape and the nature. Now move on to the 12th question in part B, second question. Determine the value of delta G naught for the following reaction given. Nickel solid plus 2 Ag plus in aqueous medium gives rise to nickel 2 plus in aqueous medium and 2 Ags. Given E naught cell is given 1.05 volt, 1 Faraday value is given, 1 Faraday is equal to 96,500 coulomb per mole. And given the E naught cell F value, we need to calculate the number of electrons transferred. And here I have written the reaction. You need not to write this. By knowing this nickel 2 plus, you can say the number of electrons transformed here is 2 electrons. Therefore, N value is 2. Write the formula delta G naught is equal to minus NF E naught of the cell. Substitute the correct values and that carries 1 mark. After writing the formula and correct substitution, it carries 1 mark. Simplify and give the value in terms of with the unit. Give the value in unit. Give the value with unit and that carries 1 mark. So need not to write in kilojoules also, just you write it in joules also, that is also correct and that carries 1 mark. So move on to the next question. For the reaction R gives P, reactant gives rise to product. The concentration of the reactant changes from 0.05 molar to 0.02 molar in 30 seconds. Calculate the average rate of the reaction. So average rate of the reaction is given by decrease in the concentration of R by time. So that is minus del R by molar concentration of R by del T. Now negative sign indicates decrease in the concentration. So it is decreased from 0.05 to 0.02. Therefore 0.02 minus 0.05 divided by 30. That is the 30 seconds time taken. So therefore you simplify it, 1 into 10 power minus 3 molar per second and that carries 1 mark. First 1 mark is for writing the formula along with the substitution. Second one, the value with the unit carries 1 mark. So here even you can also write it as 0.001 also you can write. Okay. Now move on to the next one. What is lanthanide contraction? Mention any one consequence of lanthanide contraction. So the gradual decrease in atomic or ionic radii from lanthanum to lutetium is called lanthanide contraction. So this is called lanthanide contraction that carries 1 mark. And consequences, first one, the radii of zirconium and hafnium is almost same and therefore they are very difficult to separate. Covalent character of cation increases. Electronegativity of trivalent ions increases slightly and basicity decreases from lanthanum to lutetium. So you have to write any one consequences here and any one consequence of lanthanide contraction and that carries 1 mark. definition of lanthanide contraction plus 1 consequence gives 1. 1 plus 1 mark. Now, question number 15. Complete the reaction. Methyl chloride reacts with sodium metal in presence of chlorobenzene in dry ether. So, you know the reaction. This reaction is nothing but Wurtz-Fittig reaction. So, reaction takes place with the elimination of sodium chloride. You'll get toluene or methyl benzene. So, you have to complete these two products. You have to write toluene and the sodium chloride. The reaction is Wurtz-Fittig reaction. Second one is write the general formula. Question number 15b. Write the general formula of Grignard reagent. You know the general formula of Grignard reagent. It is RMgX, and that carries 1 mark. So now move on to the write the chemical equation for the conversion of cumene to phenol. Here you have two reactions. First one is conversion of cumene to cumene hydroperoxide and cumene hydroperoxide to phenol with the formation of acetone. First you write the cumene, write the conditions. It undergoes oxidation in O2 when it is heated with O2 at 100 to 130 degrees centigrade in air. It gives cumene hydroperoxide. Remember, here you cannot write it as COOH. You need to write the bond here between the two oxygen atoms. You have to write the bond, and this linkage indicates peroxide linkage. Therefore, it is called cumene hydroperoxide. This is very important. On boiling with water at 100 degrees centigrade, you will get phenol with the formation of acetone. Writing byproduct here is very, very important. Writing the complete reaction carries 2 marks. If you write the correct half of the reaction, you can allot 1 mark. So, I hope you are evaluating your papers there. So, evaluate the papers as you already have a practice to evaluate the papers. So, you evaluate the papers because you have your papers with you, written papers with you. So, now let us move on to the question number 17. Explain Friedel-Crafts alkylation reaction of anisole with chloromethane with equation. So, this is anisole, methoxybenzene, and since there is a lone pair of electrons on the oxygen, so this is ortho and para directing. When anisole reacts with the methyl chloride, 2 molecules in presence of anhydrous aluminium chloride, at the ortho position methyl group gets substituted, and at para position methyl group gets substituted, and para product is the major product, ortho product is the minor product due to a steric hindrance. Due to steric hindrance, ortho product is the minor product. So, the name of the compound here, orthomethyl anisole or paramethyl anisole. Even you can write it as orthomethoxytoluene, paramethoxytoluene. Here, you can take the root word anisole as a root word or the toluene as a root word. Anisole anta adru root word tagobodu, toluene anta adru root word tagobodu. Anisole na root word tagondre methyl group substituent ಆಗುತ್ತೆ. toluene na ನೀವು ಏನಾದರೂ root word ಆಗಿ ತಗೊಂಡ್ರೆ methoxy group ಏನಾಗುತ್ತೆ? Methoxy group will be substituent. Anisole reacts with methyl chloride in the presence of anhydrous aluminium chloride as catalyst to form orthomethoxytoluene and paramethoxytoluene or orthomethyl anisole, paramethyl anisole. That explanation carries 1 mark and equation carries 1 mark. So next let us move on to the question number 18. Explain Hoffmann's bromamide reaction. So Hoffmann's bromamide reaction is a reaction for the preparation of primary amines. Here either you can write general reaction or the examples because it is only given explain Hoffmann's bromamide reaction. With an example, if they ask, compulsorily have to write the example. But here it is not mentioned. You can give the general reaction. Amides on heating with bromine and aqueous NaOH gives primary amines. So this reaction is called Hoffmann's bromamide reaction. This explanation carries 1 mark. And RCONH2, general formula of amide, bromine reacts with aqueous NaOH. Even you can take the potassium hydroxide also, and this undergoes reaction to give primary amine with the formation of sodium bromide, sodium carbonate and water. If you take KOH, here you will get potassium bromide and potassium carbonate. So explanation carries 1 mark and equation carries 1 mark. Now let us move on to part C. Question number 19. Write two chemical reactions with conditions involved in the manufacture of nitric acid by Ostwald's process. So here the first equation, 4NH3 ammonia gas combines with oxygen in platinum rhodium gas catalyst at 500 Kelvin and at 9 bar pressure. It gives nitric oxide with the formation of water. You have to write the balanced equation with this condition, and this carries 1 mark. And the second one, the nitric oxide undergoes oxidation to give nitrogen dioxide. Temperature should be below 100 degrees centigrade, and this carries 1 mark. And the third reaction here indicates nitrogen dioxide absorbs in water and it gives nitric acid with the liberation of nitric oxide, and it recycles back to the second step. So need not to write that sentence, just you have to write the 3 balanced equation, 1, 2 and 3. 3 equations, so that each steps carries 1 mark. Okay. Now question number 20. Give any 3 reasons for the anomalous behavior of oxygen. So the first reason here is due to its very small size. Second one, because of its very high electronegativity. Third one, as it does not having any empty d orbitals. And the fourth one is because of its high ionization enthalpy. I have given 4 reasons here. You can write any 3 and each reasons carries 1 mark, and you need to write the exact reasons whatever it is given in the scheme. Okay. Now move on to the question number 21. Complete the reactions. So chlorine reacts with cold and dilute sodium hydroxide. Remember here you will get 2 reactions even with hot and concentrated also there, but here it is given cold and dilute NaOH. You need to consider this condition. So when it reacts with chlorine with the cold and dilute NaOH, it gives sodium chloride and sodium hypochlorite. These 2 products are important. I underlined here sodium chloride and sodium hypochlorite with water. So if you forget to write the water also, you need to write these 2 products, and that carries 1 mark. And don't allot half a marks here. If you write sodium chloride means don't allot half a marks. So we cannot allot a half a marks. Ardha marks allot mado hage illa scheme alli. So you have to write both the products. If you have written both the products, then you allot 1 mark. If you have written only one product, then don't go for the half a marks. Okay. Now second reaction, calcium hydroxide reacts with chlorine and it gives a bleaching powder CaOCl taken twice with the formation of calcium chloride and water, and this carries 1 mark, and you have to write this composition CaOCl taken twice, and this is bleaching powder. Now move on to the next question. Question number 21b. Why does chlorine water loses its yellow color on standing in sunlight? So chlorine water loses its yellow color on standing in sunlight due to the formation of chlorine water jote combine adaga it gives HCl and hypochlorous acid. HOCl means hypochlorous acid. Because of the formation of these products, the chlorine water loses its yellow color on standing in sunlight. So this is the very important question, and that carries 1 mark. So let us move on to chlorine water loses its yellow color on standing in sunlight due to the formation of HCl and HOCl. HOCl antadru baribodu athwa hypochlorous acid antadru barkolbodu ನೀವು. Okay. Now move on to the question number 22. write the general valence shell electronic configuration of d block elements. They have asked valence shell electronic configuration, therefore need not to write the noble gas core. Noble gas core na bardidre marks sikkalla. So you have to write the valence shell electronic configuration n minus 1 d1 to 10 and ns 1 to 2. Only this much you have to write and need not to write here the noble gas core. Noble gas core na ಇಲ್ಲಿ ಬರೀಲಿಕ್ಕಾಗಲ್ಲ, ಬರೆಯೋ ಹಾಗಿಲ್ಲ, ಬರೆದ್ರೆ ತಪ್ಪಾಗತ್ತೆ. ಕೇಳಿರೋದು general valence shell electronic configuration. Okay, now move on to which element of next question B, which element of 3D series shows +7 oxidation state? So the valence shell ಅಲ್ಲಿ ಎಷ್ಟು electrons ಇದೆ? Manganese I have given the electronic configuration, argon core 3d5 4s2, total number of electrons is 7 here in the outermost shell. It is capable of losing 7 electrons, therefore the +7 oxidation state, highest oxidation state given by the 3D series element is nothing but manganese. You can write it in words or you can write the symbol also, that carries 1 mark. Now let us move on to among the question C, among Zn2 plus and Zn plus 3, Zn plus 2 and chromium plus 3, which is colored ion? So out of these two, chromium plus 3 is colored ion. What is the reason? Reason is it contains 3 unpaired electrons. Because of the presence of 3 unpaired electrons, chromium plus 3 is colored ion ಅಂತ ಹೇಳ್ತೀವಿ. ಸೊ ಇಲ್ಲಿ ಈ ರೀಸನ್ ಬರೆಯೋದು ಬೇಡ, just you can write Cr plus 3 and that carries 1 mark. Now move on to calculate the magnetic moment of Fe2 plus ion. So atomic number of iron 26, electronic configuration argon 3d6 4s2. After losing 2 electrons, this is 3d6. Here we have 4 unpaired electrons, okay, and n value will be 4. In the formula, mu is equal to square root of n into n plus 2. The n indicates the number of unpaired electron and substitute the value in a formula that carries 1 mark. Formula, writing the formula carries 1 mark, and write the value of n is equal to 4 and that carries 1 mark. And substitute and simplify, you will get root 24 4.89 bm Bohr magneton. If you forgot to write this unit, you won't get the marks. Along with the value, you have to write bm, that is Bohr magneton, that is the unit of dipole moment. So along with this unit you have to write, and that carries 1 mark. Okay, now move on to the next question B. Why is silver not regarded as a transition element? The silver atom has completely filled d orbital in its outermost shell, that is 4d10. When the d orbital is completely filled, then this is not regarded as a transition element. So whether they have to contain, the elements has to contain half filled d orbital or empty d orbital. If the d orbital is completely filled, then it is not regarded as a transition element. Therefore, it is not regarded as a transition element. Just you need to write due to the presence of completely filled d orbital. Just that is one sentence and that carries 1 mark. Move on to the next question. Explain hybridization, geometry and magnetic property of tetracyanonickelate 2 minus ion. Tetracyanonickelate ion on the basis of valence bond theory. Atomic number of nickel is given, that is 28. First you have to write the electronic configuration of nickel in 2 plus state. Argon 3d8. Now you have to write the block diagram to distribute the electrons. 3d8, 4s and 4p. In 3d orbital, there are 2 unpaired electrons as I have given. The 2 unpaired electrons of the 3d orbitals are forced to pair up against Hund's rule of maximum multiplicity in the presence of strong ligand. Cn minus gives a strong field ligand. Therefore, in the presence of strong ligand, these electrons are get paired up and since 4 ligands are to be accommodated, nickel 2 ion undergoes what type of hybridization? DsP2 hybridization, forming 4 equivalent DsP2 hybrid orbitals. Compulsorily you have to show this hybridization DsP2 and pairing of the electron. See here, this complete explanation carries 1 mark, and here writing the hybridization is very, very important. So you will get 4 equivalent 4 DsP2 hybrid orbitals, and the 4 hybrid orbitals overlap with the orbitals of the ligands, and the ligands donate 4 pair of electrons to form 4 coordinate bond, and hence the geometry is square planar. If you have written this word square planar geometry, then that carries 1 mark. Okay. Now, due to the absence of unpaired electrons, here the electrons are not completely paired up. Due to the absence of their unpaired electrons in the complex, it is diamagnetic complex, and this complex is inner orbital complex because DsP2 inner orbital complex, and it is also called spin paired complex and low spin complex, you can say. Another one is tetrachloronickelate, and that in that nickel undergoes sp3 hybridization, and the geometry is tetrahedral geometry, that you have to remember, the another nickel complex. Okay, now let us move on to the question number 25. Draw the diagram of d orbital splitting in octahedral complexes in crystal field. So here the metal d orbitals containing 5 d orbitals, dx square minus y square, dz square, dxy, dxz and dyz, energy increases from here to here. And this is the average energy of the d orbitals in the spherical crystal field. Then the splitting takes place here. Eg carries 2 orbitals, one is at higher energy, another one is at lower energy. Higher energy orbital is Eg, dx square minus y square, dz square, and octahedral splitting energy is plus 3 by 5 here, and this is the orbitals with lower energy carries 3 orbitals, dxy, dxz, dyz, and it is T2g, and this is the octahedral splitting energy. So this diagram only you have to write, need not to write the explanation, and don't write the reverse of it, it become tetrahedral. So therefore it is octahedral crystal field splitting, it is given octahedral complexes in crystal field is given, therefore you have to write this diagram, and this diagram carries 2 marks. And move on to the question number B in this. Write the IUPAC name of CONH3 taken 4 times, H2O taken 2 times, Cl3. So the name of this is tetraamine diaqua, tetraamine diaqua cobalt 3. 3y because these two are neutral ligands, therefore tetraamine diaqua. Cl is -1 into 3 -3, therefore cobalt 3 chloride. So the IUPAC name is tetraamine diaqua cobalt 3 chloride. That is the IUPAC name, and that carries 1 marks. Now to question number 26. Write any 3 postulates of Werner's theory of coordination complexes. A metal atom, first assumption that we can give like this: a metal atom in coordination compounds possess 2 types of valencies, namely primary and the secondary valencies, and the primary valencies are ionizable and are satisfied by negative ions. Secondary valencies are non-ionizable and are satisfied either by the neutral molecules or the negative ions. And the fourth one is primary valencies corresponds to the oxidation state of the central metal atom, and the secondary valencies corresponds to the coordination number. Illi assumptions na split mado hagilla, split maadi onnan mado hangilla. These assumptions you need to write, and each assumption carries 1 mark. Okay, then here one more is fifth one: primary valency are variable but secondary valencies are fixed anta baribodu. And primary valency is non-directional but secondary valency is directional. So complexes give different geometrical shape. Yake primary valency is non-directional, secondary valency directional ಆಗಿರೋದ್ರಿಂದ complex gives different geometrical shape. Any three assumptions you have to write and each carries 1 mark, total 3 marks. Now let us move on to the part D. What is packing efficiency? Calculate the packing efficiency in simple cubic crystal. The percentage of total space filled by the particle. The percentage of total space filled by the particles is called packing efficiency. You can write this and that carries 1 mark, and even you can write like this also. Ratio of volume occupied by the spheres in a unit cell by total volume of the unit cell into 100. Now, next question is packing efficiency in a simple cubic unit cell. This carries 1 mark. Total here it is calculate the packing efficiency in a simple cubic crystal. Illi idu 1 mark irutte, and simple cubic unit cell alli packing efficiency na calculate madidre 2 marks irutte. First you have to write how many number of atoms per unit cell is present in simple cube. It is only 1, that you have to write. And edge length of the cube be A, and radius of each atom take it as R. Therefore, A will be equal to 2R. So, need to write the diagram here. And what is the volume of unit cell? A cube, 2R whole cube, 8R cube. Very simple calculation it is. Volume of one atom you need to calculate. Volume of one sphere is given by 4/3 pi r cube. Substitute in a packing efficiency. So I have already given volume occupied by the sphere in the unit cell divided by total volume of the unit cell. So total volume of the unit cell I have given, volume of the sphere I have given into 100. So pi by 6 into 100, and it is nothing but 52.38%, and that carries 1 mark. Up to here you will get 1 mark, and the last one you will get 1 mark. Move on to the second, that is B. Copper crystallizes into FCC lattice with edge length 361 picometer. Calculate the density of crystal given. Avogadro number is given 6.022 into 10 power 23. Atomic mass of copper is also given 63.54 unified mass. Okay, now given Z is 4, number of atoms per unit cell 4 agate yakandre FCC lattice helirodrinda. Molar mass is given, and that is atomic mass. A is given, edge length 361 picometer, adana centimeter ge convert ಮಾಡ್ಕೊಳ್ಳೋಣ. So 361 into 10 power minus 10 centimeter. ಇದನ್ನ ಮತ್ತೆ ನಾ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಿದಿರಿ 3.61 into 10 to the power of minus 8 centimeter. ಇದನ್ನ as it is ಬೇಕಾದ್ರೆ ಬರ್ಕೋಬಹುದು, ಅಥವಾ ಈ ಫಾರ್ಮಿಗೆ ಕೂಡ ಕನ್ವರ್ಟ್ ಮಾಡ್ಕೋಬಹುದು. ಯಾಕಂದ್ರೆ 8 ಕ್ಯೂಬ್ ಮಾಡಿದಾಗ 24 ಆಗತ್ತೆ. ಇಲ್ಲಿ ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಸಿಂಪ್ಲಿಫೈ ಮಾಡಕ್ಕೆ ಈಸಿ ಆಗತ್ತೆ. ಹಾಗಾಗಿ I took it as a 3.61. A point na illinda hige move ಮಾಡ್ತೀವಿ. So 1 and 2. So here 10 to the power of plus 2 ಬರುತ್ತೆ. 10 to the power of minus 10 into 10 to the power of plus 2 ಅಂದ್ರೆ 10 to the power of minus 8 centimeter ಆಗುತ್ತೆ. 3.61 into 10 power minus 8 centimeter. So Avogadro number ಕೂಡ ಕೊಟ್ಟಿದ್ದಾರೆ. ಇಲ್ಲಿ ಫಾರ್ಮುಲಾ ಬರೀರಿ. D is equal to density is equal to Zm divided by A cube into Na. Substitute ಮಾಡಿ. Writing formula and correct substitution, that carries 1 mark. And simplify ಮಾಡಿ. So simplify ಮಾಡಿದಾಗ 897 10 power 1 ಇದೆ. ಈ ಡೆಸಿಮಲ್ ನ ಇಲ್ಲಿಗೆ ಹಾಕಿ 10 power minus 1 ಆಗುತ್ತೆ, ಕ್ಯಾನ್ಸಲ್ ಆಗುತ್ತೆ. 8.97 gram per centimeter cube, that you have to write. So unit with unit, and the value carries 1 mark. Okay, now move on to the question number 28. Write any 3 differences between ideal and non-ideal solutions. So any 3 differences between ideal and non-ideal solutions. Make 2 columns. First column ideal solution, second one is non-ideal solution. So ideal solution obeys Raoult's law, but non-ideal solution do not obey Raoult's law. And enthalpy, mixing, a change in volume of after mixing is 0 here. The change in the volume after mixing is not equal to 0. Enthalpy of mixing, change in enthalpy of mixing is 0 in case of ideal solution. Enthalpy change of mixing is not 0 in case of non-ideal solution. And the last one, the force of attraction between solute and a solvent molecule will be equal to the force of attraction between solute and solvent molecule. Even you can write it as force of attraction between A and B will be same as that of AA and BB. And here the force of attraction between solvent molecule, either it is greater or lesser than that of the solute and solvent molecules. Even you can write it in terms of AB. So solute ಮತ್ತೆ solvent A B ಅಂತ ಕೂಡ ಮೆನ್ಷನ್ ಮಾಡಬೇಕು. Any 3 you have to write and that carries 3 marks. Now question number B, calculate the osmotic pressure of a solution containing 0.1 molar of sucrose at 20 degrees centigrade. Temperature ಕೊಟ್ಟಿದ್ದಾರೆ, concentration ಕೊಟ್ಟಿದ್ದಾರೆ 0.1 molar. 0.1 molar means 0.1 mole per liter ಆಗುತ್ತದು. R value ಕೊಟ್ಟಿದ್ದಾರೆ 0.0821 liter atmosphere per Kelvin per mole. Temperature 20 degree, convert it into Kelvin, 293 Kelvin. So this is the formula need to calculate for osmotic pressure. Pi is equal to CRT, pi is equal to CRT, and pi is equal to concentration 0.1, substitute the value of R and this temperature, that carries 1 mark. And writing the simplification ಆದ್ಮೇಲೆ with the unit ಏನ್ value ಬರೀತೀರಾ 2.40 atmospheres and that carries 1 mark. So move on to the question number 29. Define specific conductance of electrolytic solution. How does it vary with concentration? So the specific conductance of an electrolytic solution is nothing but the conductance of electrolytic solution placed between the conductance of it is a conductance of electrolytic solution placed between two electrodes of length 1 meter apart and area of cross section 1 meter square. So this is the definition for specific conductance of electrolytic solution. How it varies with the concentration ಅಂತ ಕೇಳಿದ್ದಾರೆ. ಆ ಡೆಫಿನಿಷನ್ ಗೆ 1 mark. ಆಮೇಲೆ ಸ್ಪೆಸಿಫಿಕ್ ಕಂಡಕ್ಟೆನ್ಸ್ ವೇರೀಸ್ ಅಂತ ಕೇಳಿರೋದ್ರಿಂದ ಇನ್ವರ್ಸ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್ ಅಂತಾನು ಬರೀಬಹುದು. ಇಫ್ ಯು ಯೂಸ್ ದ ವರ್ಡ್ ಇನ್ವರ್ಸ್ಲಿ ಪ್ರಪೋರ್ಷನಲ್, ದಟ್ ಕ್ಯಾರೀಸ್ 1 mark. ಆರ್ ಎಲ್ಸ್ ಯು ಕ್ಯಾನ್ ಸೇ ಸ್ಪೆಸಿಫಿಕ್ ಕಂಡಕ್ಟೆನ್ಸ್ ಡಿಕ್ರೀಸಸ್ ವಿತ್ ಡೈಲ್ಯೂಷನ್, ಡಿಕ್ರೀಸಸ್ ವಿತ್ ಡೈಲ್ಯೂಷನ್ ಅಂತ ಕೂಡ ಬರೀಬಹುದು. ದಟ್ ಕ್ಯಾರೀಸ್ 1 mark. ರೀಸನ್ ಏನು ಅಂತಾನು ಕೇಳ್ಬೋದು ನಿಮಗೆ ಕ್ವಶನ್. ಇದ್ರಲ್ಲಿ ಇಲ್ಲ, ನೀಡ್ ನಾಟ್ ಟು ರೈಟ್ ದಿಸ್, ಜಸ್ಟ್ ಐ ಹ್ಯಾವ್ ಗಿವನ್ information. Why the concentration, as the concentration increases, specific conductance decreases? Because the on dilution or after dilution, if the dilution increases, total number of ions per meter cube of a solution decreases. Total number of ions decrease ಆಗುತ್ತೆ. So ಹಾಗಾಗಿ specific conductance ಕೂಡ ಏನಾಗುತ್ತೆ, decrease ಆಗ್ತಾ ಹೋಗುತ್ತೆ. Now move on to the question number B, state Colorast law. So it states that I have given two statements here. You can write any one of the statements here. It states that the molar conductance of an electrolyte at infinite dilution is equal to sum of the ionic conductance of cation and anion respectively. Or even you can write, it states that limiting molar conductivity of an electrolyte can be represented as sum of the individual contributions of anion and the cation of the electrolyte. That also you can write. Okay, that carries 1 mark. Second one, calculate limiting molar conductivity lambda m naught of acetic acid given the limiting molar conductivity of H plus ion, that is cation, with unit, and limiting molar conductivity of acetate ion is also given, that is also given as 40.9 Simon centimeter square per mole. It is given. It is as we have given the statement here, like that you need to take the sum of the molar limiting conductivity of anion and the cation. You have to write sum these, and what you get 390.5 is the limiting molar conductivity of acetic acid. So the writing the formula along with the correct substitution carries 1 mark here, and the simplification carries 1 mark, total 2 marks. Okay, now so here it carries 1 mark. Now move on to the question number 30. Derive the integrated rate expression for first order reaction. So integrated rate expression for first order reaction you have to write. So consider a first order reaction. R gives P. A first order reaction is one in which the rate is directly proportional to first power of the concentration of the reactant R. First power of the concentration of the reactant R. So first form you have to write like this, then remove the proportionality constant, or you can also write it as minus D, that is decrease in the concentration, molar concentration of reactant with time, or you can also write Kr. Okay, rearrange the equation, what you get. So if you rearrange this equation, dr by r is equal to minus k into dt. So integrate this equation. After integration, you will get ln r is equal to minus kt plus I. So I is the constant of integration and its values can be determined easily. If you put t is equal to 0, r will be equal to r naught. What is r naught? Mentioning r naught is very, very important here. So r naught is the initial concentration of the reactant, and substitute here the values of t and r, then you will get I is equal to ln r naught, that carries 1 mark. And substitute the value of I in the equation, substitute 2 in 1. So simplify it, and what you get, minus kt is equal to ln r by r naught. So to remove the negative sign here, just to take a reciprocal of it, what you get, kt is equal to ln r naught by r. So what is k? 1 by t ln r naught by r, and k is equal to, take ln to log convert ಮಾಡಿ ಈ ಬೇಸ್ ಇಂದ ಬೇಸ್ 10 ಗೆ ಆಗ 2.303 ದ ಮಲ್ಟಿಪ್ಲೈ ಮಾಡಬೇಕು. ಸೊ k is equal to 2.303 by t log r naught by r. This carries 1 mark. I have given how to split the mark here. First, writing the rate equation carries 1 mark, and calculation of I value carries 1 mark, and the final expression carries 1 mark. Okay, now move on to the next question here. What is the order of reaction if its rate is independent of concentration of reactants? Draw the graph of concentration versus time for such a reaction. So definitely when the rate is independent of concentration of the reactant means it is definitely a zero order reaction. This carries 1 mark. And draw the graph here, concentration of R versus time. So ಇಲ್ಲಿ x axis ಅಲ್ಲಿ time ತಗೋತೀರಾ, y axis ಅಲ್ಲಿ concentration of R ತಗೋತೀರಾ, and you will get a negative slope, and it is nothing but k, and this gives intercept gives R naught. So this graphical representation carries 1 mark. Now move on to the question number 31. What is observed? What is observed when a beam of light is passed through colloidal solution? When a beam of light is passed through a colloidal solution, the path of light is rendered visible in the form of a cone, and that is called Tyndall cone. Tyndall cone is observed. That also you can write, but you need to write this explanation. That carries 1 mark. So if you write, this cone is nothing but Tyndall cone. Second question. An electric current is passed through a colloidal solution. Depending on the charge on a colloidal solution, so if it is negatively charged, so in the movement of the colloidal particle takes place when on passing electric current either towards anode or towards cathode. So that takes place under the influence of electric current depending on the charge on the colloidal particles. Negative charge idre anode kadege move agutte, positive charge idre cathode kadege move agutte. That you have to mention, and that carries 1 mark. Okay, now move on to this. An electrolyte sodium chloride is added to ferric hydroxide salt. It is an electrolyte. The electrolyte sodium chloride, when it is added to ferric hydroxide salt, the coagulation or the precipitation of the salt takes place. Just you have to write coagulation or precipitation takes place. So that carries 1 mark. Move on to why is adsorption process always exothermic? As we know that delta H is negative for adsorption process. What is the reason they are asking? So during adsorption, what happens? There is an always decrease in the residual forces on the surface of the adsorbent. Whatever the residual forces present on the surface of the adsorbent, that decreases after the adsorption. So which liberates in the form of heat, because it is a force of attraction between adsorbate and the adsorbent, and that force of attraction liberates the energy in the form of heat, and therefore adsorption process is always exothermic, and that carries 2 marks. Move on to the part D here. Explain the mechanism of SN1 reaction by taking an example of tertiary butyl bromide as an example. Here you need to write the equation exactly as it is given with the conditions here. Slow, RDS, and this reaction is fast. See here, the mechanism involves 2 steps. The tertiary butyl bromide ionizes slowly to give sp2 hybridized and planar tertiary butyl carbocation. Don't forget to write the positive sign here and write the reversible condition. Here you need to mention the slow, and since it is the slowest step, it is the rate determining step. If you write it in a proper way, if you have written the equation properly, then it carries 1 mark. Illi positive charge bardilla andre alli 1 marks kodlike baralla, yakandre idu carbocation. This is important point. Second step, the nucleophile OH minus ion from the aqueous NaOH or the KOH attacks the tertiary carbocation from both the sides because it is planar, and it may result in the formation of this compound or this compound. Anyone you can write, because tertiary butyl alcohol obtained is a racemic mixture here. The product is racemic mixture. Racemization takes place in a case of SN1 mechanism, and this step carries 2 marks. Total 3 marks. Okay. Explanation carries 1 mark and 2 equations carries 1 each. That is total 3 marks. Write the structure of A and B. Question number B. Write the structure of A and B in the following reaction. So this is 1, 2, 3, 4, 5, 6. 2 bromohexane is given. 2 bromohexane on heating with alcoholic KOH. So here it is a beta elimination and the reaction is dehydrohalogenation. The hydrogen can be eliminated from this carbon or this carbon because both are beta carbon atoms. When this is the case, if a given haloalkane containing 2 different beta carbon atoms and the products are 2 here, one is the major product, another one is the minor product. A is hex 2 in, B is hex 1 in. Here A is the major product according to Setsev's rule, because highly substituted alkene is more stable due to hyperconjugation effect. So this carries 2 marks. Writing the 2 products carries 2 marks, 1 mark and 1 mark. Now, move on to the question number 33. Explain the mechanism of dehydration of ethanol to ethene. So, first step is formation of protonated alcohol. Protonation takes place and the reaction is fast, and you will get ethyl oxonium ion. OM, oxonium ಯಾಕೆ ಬರುತ್ತೆ ಅಂದ್ರೆ ಇಲ್ಲಿ ಆಕ್ಷನ್ ಮೇಲೆ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಬರುತ್ತೆ. 1 pair of electron ಬಾಂಡ್ ಫಾರ್ಮೇಷನ್ ಯೂಸ್ ಮಾಡ್ಕೊಳ್ಳೋದ್ರಿಂದ ethyl oxonium ion. That carries 1 mark. Second step, protonated alcohol loses a molecule of water to form carbocation, and that carbocation is ethyl carbocation, and this step is slow and it is a rate determining step. Illi bond cleavage ಆಗುತ್ತೆ. ಈ ಬಾಂಡ್ ಇದಕ್ಕೆ ಶಿಫ್ಟ್ ಆದಾಗ ಈ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ನ್ಯೂಟ್ರಲ್ ಆಗಿ ವಾಟರ್ ಎಲಿಮಿನೇಟ್ ಆಗುತ್ತೆ. ಫಸ್ಟ್ ಸ್ಟೆಪ್ ಅಲ್ಲಿ ಯೂಸ್ ಮಾಡಿರೋ ವಾಟರ್ ಎಲಿಮಿನೇಟ್ ಆಗುತ್ತೆ ಇಲ್ಲಿ, and it gives a ethyl carbocation. What is the third step? The loss of proton takes place from ethyl carbocation. E proton loss agate, e bond illik shift adaga you will get ethene with the formation of H+. So this is the 3 steps involved in a mechanism. Each step carries 1 mark. So you need to show the direction properly. Now arrange the following in the increasing order of their acidic strength: water, ethanol and phenol. So the increasing order is ethanol is weaker acid, then comes water, then comes phenol. Here we have ethyl group. Ethyl group is electron releasing, and electron releasing group decreases the acidic strength. And in water we have hydrogen. It is not electron releasing and not electron withdrawing. And in phenol, phenyl group is there, benzene ring, and that phenyl group is electron withdrawing group, and it increases the acidic strength. So this is the increasing order of the acidic strength of water, ethanol and phenol. Now move on to the question number C. Here, write the chemical equation of conversion of phenol to picric acid. Picric acid is given, therefore we need to use the nitrating mixture. If you want to prepare orthonitrophenol and paranitrophenol, we have to use the dilute nitric acid, but here we need to use when phenol is heated with concentrated nitric acid in presence of concentrated sulfuric acid, you will get 2,4,6 trinitrophenol, and it is nothing but picric acid. Only equation you have to write, need not to write the explanation, that carries 1 mark. Now explain the Cannizzaro reaction by taking formaldehyde as an example. What is Cannizzaro reaction? It is a reaction for aldehydes not containing alpha hydrogen. We can give 2 examples. One is formaldehyde, another one is benzaldehyde. Here it is formaldehyde we need to use. Therefore, when 2 molecules of formaldehyde which do not contain alpha hydrogen atom react with strong solution of NaOH. This is very, very important. Strong solution you need to mention. Strong solution of NaOH or KOH undergoes disproportionation reaction. Disproportionation means one molecule undergoes oxidation, the same molecule of the same compound undergoes reduction. So that after disproportionation, it gives one molecule is oxidized, reduced to methyl alcohol, another molecule of formaldehyde is oxidized to salt of formic acid. Salt of formic acid, that is called potassium formate. So this reaction is called Cannizzaro reaction. Explanation carries 1 mark and equation carries 1 mark. Now complete the following reactions. So here 2 molecules of acetaldehyde given when it is heated with dilute NaOH. If you look at the dilute NaOH, it is confirmed that it is undergoing aldol condensation because acetaldehyde containing alpha hydrogen. Correct. When this undergoes aldol condensation, you will get 3-hydroxybutanol, that is aldol, and which on heating loses a molecule of water, OH from here and H from here, and it gives but2 in 1-ol. 1, 2, 3, 4. but2 in 1-ol, and it is called crotonaldehyde. Just you have to write only this product here, 3-hydroxy, 1, 2, 3, 3-hydroxybutanol or aldol. So if you write this product, then that carries 1 mark. Just you write this product and this carries 1 mark. So the reaction is aldol condensation. Next one is acetone or any ketone which containing alkyl group here, that is alpha methyl group, when it is heated with sodium hypochlorite. That means to say when it is treated with sodium hydroxide and chlorine, it gives sodium hypochlorite. If you look at this compound, means the reaction is again a haloform reaction. So this group undergoes oxidation, correct? So here is a alpha hydrogen, here is also alpha hydrogen. Methoxy ketone group, it may be R or may be hydrogen or the methyl group here, but alpha hydrogen, alpha methyl group already there in the ketone. So haloform is a reaction for ketones. It is nothing but a special oxidation which the ketone must containing alpha methyl group. This is the oxidation of alpha methyl ketones. So since it containing alpha methyl group, this undergoes oxidation. Ketone group undergoes oxidation to respective sodium salt it gives, and methyl group gets converted to respective halo form, that here it is chloroform, and the reaction is haloform reaction. Only you need to write the reaction because chloroform is given. By knowing the byproduct, you can write the main product here, RCOONA, sodium salt of carboxylic acid. If you write this, it carries 1 mark. Now move on to the third one. Benzaldehyde is heated with nitric acid and sulfuric acid between the temperature 273 to 293 Kelvin here. And since it is a meta-directing compound, it gives meta-nitrobenzaldehyde. If you write a NO2 group here, then it is wrong. To this position, this is meta position. Therefore, meta-nitrobenzaldehyde, because CHO group is meta-directing, and that carries 1 mark. Question number 35. A. By general equation, explain the preparation of carboxylic acid from Grignard reagent. If you say Grignard reagent, definitely the another reacting molecule will be dry ice. Dry ice means solid carbon dioxide. Grignard reagent reacts with solid carbon dioxide, that is dry ice, to form salts of carboxylic acid, which on acid hydrolysis gives carboxylic acid. So this explanation carries 1 mark. And this is the reaction Grignard reagent RMGX. ಇಲ್ಲಿ ಜನರಲ್ ಈಕ್ವೇಶನ್ ಕೇಳಿರೋದ್ರಿಂದ RMGX ತಗೋಬೇಕು, ಎಕ್ಸಾಂಪಲ್ ತಗೊಳ್ಳೋ ಹಾಗಿಲ್ಲ. ಎಕ್ಸಾಂಪಲ್ ತಗೊಂಡ್ರೆ ಮಾರ್ಕ್ಸ್ ಇರಲ್ಲ. RMGX, so the negative part add on to the carbonyl carbon, positive carbonyl carbon, then the shifting of this bond takes place and you will get this compound, and this is attacked by the oxygen, negatively charged oxygen. So you'll get this product, that is addition product, RC double bond OOMGX, which on acid hydrolysis you'll get carboxylic acid and the magnesium hydroxy halide, that is the byproduct. So 1 mark is for equation and 1 mark is for explanation. Next question B. Which is more acidic between ethanoic acid and chloroethanoic acid? Which is more acidic? Definitely chloroethanoic acid is more acidic. What is the reason? So give reason anta ide alli question alli, illi bardilla nanu. So reason, this is because of the stability, carboxylate ion stability here, that is ethanoate ion stability increases because of the negative effect of more electronegative chlorine atom. Chloroethanoic acid alli chlorine atom irodrinda it exerts negative inductive effect and it increases the stability of the anion of the ethanoic acid, and that is called carboxylate ion. So carboxylate ion na stability increase madodrinda, so due to negative inductive effect of more electronegative chlorine atom, so the chloroethanoic acid is more acidic. So which is more acidic carries 1 mark, and why carries the 1 mark? Give reason carries 1 mark. Question number C. Write the equation for decarboxylation reaction of carboxylic acid using soda lime. What do you mean by decarboxylation? The process of removal of carbon dioxide from the sodium salt of carboxylic acid by heating it with sodium hydroxide and calcium oxide, soda lime, and it gives a respective hydrocarbon with the formation of sodium carbonate. Just you need to write this equation, and this mixture is called soda lime, NaOH and calcium oxide. This carries 1 mark. So move on to the next question. Explain the reaction of primary amines with Heisenberg reagent with equation. What is explain the reaction of primary amines with Hinsberg's reagent with equation. As we know that Hinsberg reagent, that is nothing but benzene sulfonyl chloride, which is used to distinguish primary, secondary and tertiary amine. So here primary amine reacts with Hinsberg reagent to form N-alkyl benzene sulfonamide, that is the product, and it is soluble in alkali. Writing explanation, and this equation carries 1 plus 1, 2 marks. Okay, so this is benzene sulfonyl chloride called Hinsberg's reagent. When it reacts with ethylamine, I took primary amine as a ethylamine. When it reacts to give N-ethyl benzene sulfonamide and with the formation of HCl, and this is soluble in alkali because of the presence of acidic hydrogen. Since this hydrogen is present next to the highly electronegative or highly electron withdrawing group here, it acts as an acidic hydrogen, therefore it is soluble in alkali. So question number B. Write the product for the following reactions. Aniline reacts with acetyl chloride and it gives N-phenyl ethanamide or N-phenyl acetanilide, or the compound is also called acetanilide, or you can write it as N-phenyl ethanamide or acetamide. You can write N-phenyl acetamide or N-phenyl ethanamide. You can also call it as acetanilide. So write the product. This is the product and that carries 1 mark. And when aniline is treated with sodium nitrite in dilute HCl, that is, this is called the reagent used for diazotization. Look at this, 0 degree centigrade. It gives out a nitrous acid and therefore it forms benzene diazonium chloride, BDC, and the reaction is diazotization, and this carries 1 mark. Now arrange the following in the decreasing order of their basic strength. So ethylamine, ammonia and aniline is given. Ethylamine is more basic, then comes ammonia, then comes aniline, and you know the reason. Electron releasing group increases the basic strength and electron withdrawing group decreases the basic strength, and therefore ethyl group is electron releasing, phenyl group is electron withdrawing. Therefore this is the order that carries 1 mark. Move on to the question number 37. Write the Howard structure of alpha D minus fructofuranose. Pentagonal structure baribeku, which carrying 5 atoms, 1 oxygen and 4 carbon atoms. So fructofuranose, fructofuranose you have to write. So alpha you have to write, alpha structure you have to write. So alpha structure alli second carbon ige CH2OH ಮೇಲಿರುತ್ತೆ, is looking upward, and OH will be in a downward direction. So this is the structure of alpha D minus fructofuranose. 1 2 3 4 5 6 ಇಲ್ಲಿ arrangement of groups correct ಆಗಿರಬೇಕು, ನೋಡಿಕೊಂಡು 1 mark, it carries 1 mark. Then move on to what is Zwitter ion. Write the general formula of Zwitter ion. So this structure carries 2 marks. This structure carries 2 marks. Fructofuranose carries 2 marks. What is Zwitter ion? Write the general formula of Zwitter ion. In aqueous solution, this is amino acid, ಇಲ್ಲಿ COOH ಇರುತ್ತೆ, ಇಲ್ಲಿ NH2 ಇರುತ್ತೆ. aqueous solution ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ, the carboxylic acid group donates proton to the amino group. When proton donate ಮಾಡಿದಾಗ this becomes COO minus and NH3 plus. Both positive and negative charges are present on the same molecule, therefore it becomes a dipolar ion. This dipolar ion is known as Zwitter ion anta karitevi. So the definition carries 1 mark, and the general formula of Zwitter ion idu complete agi baribeku, this carries 1 mark. And the last question, name the base which is present only in RNA, that is uracil. ಇದೇ ನಾವು ಓನ್ಲಿ ಇನ್ DNA ಅಂದ್ರೆ ಥೈಮೈನ್ ಅಂತ ಬರಿಬೇಕಾಗತ್ತೆ. ಸೊ ನೇಮ್ ದ ಬೇಸ್ ಪ್ರೆಸೆಂಟ್ ಓನ್ಲಿ ಇನ್ RNA is uracil, that carries 1 mark. So this is the discussion, students, regarding the preparatory examination paper 1. Evaluate your papers. Hope ಚೆನ್ನಾಗಿ ಮಾರ್ಕ್ಸ್ ತಗೊಂಡಿದ್ದೀರಾ ಅನ್ಕೊಳ್ತೀನಿ. ಈಸಿ ಇದೆ ಪೇಪರು, ಚೆನ್ನಾಗಿ ಅಟೆಂಡ್ ಮಾಡಿದ್ದೀರಾ ಅಂತ ಅನ್ಕೊಳ್ತೀನಿ. And thank you one and all. Thank you.